This is a problem from your lab, section 3.10. They want us to find the linear approximation of the function g of x is equal to the ninth root of 1 plus x at the point x equals 0, or they're calling it a is equal to 0. Use it to approximate the numbers 0.95 and 1.1, then to illustrate by graphing g and the tangent line. The tangent line will come from the linearization. So a linearization is going to be this equation, L is equal to this. By the way, if we look at that and going backwards, we can replace L with y, because it's really just a y value of something. And then we can subtract the g of a over to the other side. And then if we divide by x minus a, we're going to get g prime of a is going to equal to y minus g of a divided by x minus a. So that's kind of like the slope formula. So let's get a visual of that just so it's kind of clear where this linearization comes from. We're going to divide by this expression. And let's do this using parentheses, and then that should pop up, and here we go. It's a difference of the y's divided by a difference in the x's, so it's really, that's where that's coming from. Anyways, the first step is to find the derivative of g, and so if we write g as this x plus 1 to the 1/9 power, we're going to get 1 over 9. That's a constant sitting out there. And then we have x plus 1 raised to the power minus 1, so 1/9 minus 1. So if we have 1 over 9 minus 1, and we treat 1 as 9 over 9, then we're going to get negative 8 over 9. And then after that, we're going to put 0 in for x, or when a is equal to 0, we're going to put 0 in for that. So this is going to be equal to 1. 1 to any power is going to be 1, and then all we have left is a 1/9. So we have that information. Now we have g of 0 is equal to, if this is my g function, I put 0 in for x, I'm just going to get 1. So I have g of 0 is equal to 1, and now I want to write this equation. So this is going to be g of 0 plus g prime of 0, we got that to be 1/9, times x minus 0. Well, let's just put x over here. So this is our linearization. Now that we have this, we'll use this to approximate this value over here. And so I want to write that as 1 plus something. And so if we write this as 1 plus something, we're actually subtracting negative 0.05. So we can think about that as adding a negative 0.05. So that is the number that we're going to put into our linearization. So we're going to put that number in. That's minus 0.05. And then we're going to do the calculations. Well, just use a calculator for this. I have a 0.05 negative, and I want to divide that by 9. And then after that, I want to add 1 to it. So I have 0.994, round off to 3 decimal places. I think it's just going to be 0.994. And I want to do the same thing over here. So a 0.1 added to 1 will give me 1.1, and so I would add 0.1 there. Not add, but I would take my linearization, and I'm going to put 0.1 in for x. It's a positive 0.1 this time. So now I have a 0.1 divided by 9. And then I'm going to add 1 to it. So I round off to 3 decimal places. It's 1.011. A 1 keeps going forever, so that's all we need. Illustrate by graphing this in the tangent line. So I have in my Desmos calculator the graph of 1 plus x to the 1/9 power. So if I just throw in the tangent line, which is 1/9 x plus 1, I'm going to have this tangent line over here. If we zoom in, what we found here is from this graph at point, what did we do? X, we approximated, the first one we approximated was when x is equal to 0.05, negative 0.05. So negative 0.05 is right around here. The exact value is 0.9943, and if you follow this line to negative 0.05, we're going to get fairly close to the value that we got. All right, so that's how the graphs would look like. Let's see. It has to be tangent here at 0. So this looks like it's tangent a little bit to the left. This looks like it's tangent to a little bit on the right, and etc. So this looks like it's the only one that's tangent at 0. So this should be our final answer. Okay, looks good.